This is the end, beautiful friend. This is the end, my only friend. The end of our elaborate plans. The end of everything that stands. The end, no safety or surprise. The end, I'll never look into your eyes again. Can you picture what will be so limitless and free? Desperately in need of some stranger's hand in a desperate land. Lost in a romance, wilderness of pain, and all the children are insane. All the children are insane. Waiting for the summer rain, There's danger on the edge of town. Ride the King's Highway, baby. Weird scenes inside the gold mine. Ride the highway west, baby. Ride the snake, ride the snake to the lake, the ancient lake, baby. The snake is long, 7 miles. Ride the snake. He's old and his skin is cold. The West is the best. The West is the best. Get here and we'll do the rest. The bluebird is calling us. The killer awoke before dawn. He put his boots on. He took a face from the ancient gallery and he walked on down the hall. He went into the room where his sister lived, and then he paid a visit to his brother, and then he walked on down the hall, and he came to a door, and he looked inside. Father, yes, son, I want to kill you. Mother, I want to. Come on, baby, take a chance with us. Come on, baby, take a chance with us. Come on, baby, take a chance with us and meet me at the back of the blue bus. Do not blue rock on that blue bus.
All right, so this is going to be our last review. Remember that we won't be meeting on Friday. There's no live stream on Friday. Instead, the next time I see you, it'll be on Wednesday next week for your final exam. Also, keep in mind the other things, your last hack for this week, any redo opportunity that you're going to take advantage of. So far, only a few people have, and we're already halfway through the week. So if you're going to do that, do not wait to the last minute because there won't be any consideration after the last help hours on Friday. And they might be swamped with folks that are waiting for the last minute. So I decided to go back further. If you're interested in the final from 2 years ago, 2023, we live streamed that this morning, and you can go ahead and watch that live stream. I didn't want to redo it. Instead, I went back in the archive and I found this one from 2018. And there was another problem on it, but it was just fizz buzz, and that's not interesting. So this problem involves Pokemon. It's a game. If you've never played it, that's fine. Neither have I. But I was at least able to write this as an exercise. It's a game where animals fight each other, fictional animals. Each Pokemon has a type of attack or defense. For example, ice. There's an ice type. There's a grass type. There's a fire type. And so when you somebody or one of them of type A attacks against a defense of type B, there might be what's called a force multiplier. 0% means that it's not effective at all. 50% means half as effective. 100% is normal, and then 200% is super effective. And here's a visualization of that. For example, if a fire type attacks, I don't know, an ice type, it's super effective because fire melts ice, apparently, right? Otherwise, if a fire type attacks a water type, I assume that's a water type, then it's only half as effective because water puts out fire, right? And so you've got all these types of normal, fire, water, electric, all the way down to steel and fairy, right? And there's an entire grid here. Now, this is a visualization of the grid, but what we've done is we've taken that visualization and flattened it out into a file where this is the attack type, this is the defense type, and this is the associated multiplier here, right? So all the pairs are represented in this file called Pokemon types.dat, right? Each one of these pieces of data is separated by a single space, okay? Now what we're going to do with this is we're going to open up another file called Pokemon.csv, and it has a list of all of the Pokemon, at least the first 151 of them, right? So I'm sure that there are a lot more now, but whatever, right? And so like 001 is Bulbasaur, and his type is grass. 68 is Machamp and fighting, right? If that's how you pronounce it. Et cetera, all the way down to 151, which is Mew and it's psychic, right? So what we want to do is we want to produce a program that you can provide two names of Pokemon. Jinx attacks Flareon, and it should output a message like this. Jinx, which is ice type, attacks Flareon, which is fire type, and does half as much damage. Okay. Now this is going to involve processing two different files. All right. First of all, we've given you some starter code here. Right? Let's go ahead and take a look at the starter code. We've got a deep string copy function. We've got a function called split. All right. Now let's read what this function does. It's a utility function that splits a string into an array of characters along a provided single character delimiter. Right? The last parameter is used to inform the calling function of how many tokens it found and thus the size of the returned string. Right? It returns a char star star. Why is that? It returns an array of strings, each one of those tokens. In other words, strtok, we've put it on steroids and given it to you for free, right? It gives you the entire array of strings. Okay. We also give you a free function to free the entire string array. Okay. What else? Then we've given you all the implementations of these things. So there's what split looks like. It does use it counts up the number of delimiters. Then it produces the array, and then it does use strtok internally, but it does it all in one shot for you. Okay. All right. So we're over here now in the main. We've got Pokemon name 1 and Pokemon name 2. The first thing we need to do is we need to find the types of each one of those Pokemon. Okay. We could just simply open up the file here, right? Or I guess this is the file, CSV file here. And what we could do is we could go through and, okay, is that the one I'm looking for? No. Is that the one I'm looking for? No. Is that the one I'm looking for? Yes. Right? But I'd have to, juggle two of these. Is this the first one or is this the second one? Right? So what I want to do is I want to actually define a structure for this, because I'm going to read in all the Pokemon. I'm going to read in all the Pokemon and keep track of what else? Their ID, their name, and their type. Okay? So let's define a structure to do that, because it's a review. Type def struct, right? And then inside of that, I put all the member variables. The first one is going to be the ID, which I'll just use as an ID, an integer here. Then the name, which is going to be a char star. Right? Okay. And then finally the type, which is also going to be a char star. One of the things that we noticed in this, not this week's hack, but last week's hack, is a lot of people for their airports or whatever it was were hard coding string lengths, right? And that's not a great practice because what they probably did is they decided on a length and then they found then it crashed and I'll just make it bigger or something, right? And that's not the way to go about doing it because we could always give you another test case where we broke your code, right? All right, so those are the three things that I want to keep track of, and I'll call this Pokemon. All right, there we go. Okay. It's not Pokemons or Pokemon or whatever it is, whatever the plural of it is. Right? It's probably the same anyway, right? It's just one of them, okay? Now that I've defined this, let's go ahead and load up all of the Pokemon. Right? Well, first of all, I'm going to notice here that, well, you could probably hard code the value here, 151, right? Because there are only 151 Pokemon. If I didn't want to hard code that value, then what would I do? I'd go through the file, count up the number of lines, and say, okay, there are 151 entries, and so I will go ahead and create an array of 151, right? So Pokemon star Pokemon, right, is equal to, I assume that that's the plural too, is equal to Pokemon star a call to malloc. And how many bytes do you want to store 151 Pokemon? 151 times size of the structure that I just wrote. Okay. So I'll leave in a to do here. To do. Come back and fix this to be dynamic. Right. In other words, you're going to read all the lines in because I believe that there are more Pokemon right now. Right. Hundreds or thousands. Right. You got to sell more cards. So and you got to sell more games. So you got to create new ones all the time. Right. All right, but for now, we'll just go ahead and go with 151 of them, okay? Now I need to open up the file and process them and create each one of these Pokemon. So help me out. How do I open up a file? I need a file pointer first, right? And I'll go ahead and call this F for now, right? Is equal to fopen, right? And the file that I want to open is this Pokemon.csv file. Pokemon.csv, and it's in the same current directory. I'll just go ahead and hard code that. And I want to open up for the purposes of reading. Right? Okay. Once that's open, I can now read it line by line using fgetS. Right? So I need a buffer to do that, and we'll just go ahead and create a buffer that's large enough for any one of those lines. Right? And then a string. Actually, I don't need a token, right? A token string, right? Like this char star line. Because I would call forgets and over again until that's null. If I'm going to hard code this value right here, I might as well reuse it. So int num Pokemon is equal to 151. And if I know exactly how many lines I'm going to be reading, then do I need to use a while loop? I can use a regular old for loop. Right? For I is less than number of Pokemon, I plus plus. Okay. Now let's get the line. So forgets, and I don't need to capture the value because I'm not using it as a control structure for my loop. So forgets, and that's going to be, you're going to read it into buffer, at most 1,000 minus 1 characters because the null terminating character is put in there automatically for you, and you're going to be reading from the file. I didn't have to look that up because it's the same pattern, right? If int x is equal to 42, you take the thing on the right-hand side and you put it into the thing on the left-hand side. So you're reading from this thing right here on the right to this thing here on the left. Right? I've got one single line. Now what I can do is I can use this split function here. Right? Let's go ahead and split that buffer or that line. Right? So token char tokens is equal to split the buffer, and we're going to split it along commas because it's a CSV file, comma separated value file. See, each one of those things is separated by a comma. Okay. Once I've got that, now I've got 3 strings. Tokens of 0 is the ID. Tokens of 1 is the name. Tokens of 2 is the type, right? Because that's what it looks like over here. So all I'm going to do is take those 3 things and put it into the ith Pokemon. Right? So normally I would write an init function for it. We'll go ahead and do that here in a second. But let's go ahead and do it manually here first. So Pokemon of I dot ID is equal to tokens of 0. Now my first question here is, why did I do a dot? Pokemon is a pointer. So when I reference one of them, right, by using an index variable, it becomes a regular old structure. So I use the dot operator to access the ID. Now the ID is an integer. So can I assign it tokens of 0? That's a character array. That's a string, right? How do I convert a string over to an integer? A to I. There we go. All right, and that takes care of the first one. Can I do the following with the name? Pokemon of I dot name is equal to tokens of 1. Can I do that? Is that how you copy a string? I mean, it'll make this pointer point to that thing over there, but that thing over there is going to get overwritten as you go along. Right? So I need to deep copy it. Fortunately, we gave you a deep copy function that you can reuse, or that we gave them when they were taking this test. They're long gone. This is in 2018. Right? All right, so deep copy, or I guess is equal to deep copy of tokens of 1. Likewise with the type, Pokemon of I dot type is equal to deep copy of tokens of 02. There. Now, wouldn't that look nice if these 3 lines of code were in their own function, right? So to do, make an init Pokemon function and move this functionality. So it's just one single line, right? Okay. For now, though, I just want to make sure that I read them incorrectly. So let's go ahead and for int I. Let's steal this up here. Steal this. All right. And I'm going to print out each Pokemon. So printf %d %s end the line, and this will be Pokemon of I dot ID. Pokemon of I dot name and type. This is just an ad hoc testing, right? I want to make sure that I read in the file correctly and that it's working and it's not like crashing or anything. Let's see. This is a review, so GCC, just everything together. Right? Oops. Too few arguments. What was in split? Oh yeah, n, the number of. I'm expecting 3, right? So int num tokens. So let's go ahead and pass that in. And just as a sanity check, if you really wanted to, actually here, is that how I can pass in an integer by reference? That's a regular old variable, so how do I change that into a pointer? Ampersand. And as a sanity check here, I can say if num tokens is not equal to 3, something severely went wrong with the file. Printf error. Error. Expected 3 tokens. Right. Okay. All right, there we go. And buffer. Oops. What's wrong with buffer? You need a type in front of it. There we go. All right, so let's run this. And it should just print out the Pokemon. Oh, I guess I need foo and bar for now. Those aren't real, right? All right, so Mew Psychic is 151. I think that was right, isn't it? 151 Mew Psychic, and then the what's number 1? Bulbasaur Grass. Yep, we're good. And I assume that the other 150 of them are fine too. Okay. All right. I am convinced that we have successfully read in all of the Pokemon and are storing them in an array of structures to represent them. What do we need to do now? We need to find the first Pokemon, and we need to find the second Pokemon. Because we need to look up their types. Once we've got their types, we know that this type is battling this type. And then we can process this file over here and find that, oh, it was a rock versus water. Then there's our value right there. But first, I need to find the types. Right? So how do I find the first Pokemon type? Well, Another thing that we're still grading, but we're looking through Hack 13, searching and sorting, and a lot of people miss the whole point of it, that you don't roll your own, right? You don't write your own algorithm to go through. You use searching and sorting. Use Q-sort and B-search in order to do to find a New York airport or a large airport or something like that. At the very least, use L-find or L-search, which are the linear versions of those, if you really didn't want to sort for some reason. I do want to sort here, and I do want to use B-search to find each one of those Pokemon. So how could I Q-sort the Pokemon so that I'm searching for the first one and the second one? Well, the criteria that you run this on are the names, whoever Jinx is and whoever Flareon is, right? So let's go ahead and sort them by the name. Because right now, it's not sorted by the name, it's sorted by the ID, right? Because that's what the input file was. And I want to sort them by the name here so that I can search them by the name, right? So to sort that, it's going to be Pokemon, the thing that you're trying to sort. The second one is going to be 151, which I put into a num Pokemon. That's the size of the array. The third one is the size of each element in the array, Pokemon, right? As in the number of bytes to compare. And then the last one is going to be my comparator, CMP Pokemon by name. Right? Now that doesn't exist yet, so we're going to have to create it. Right? So let's come over here to our header file and remind me, what is the prototype for a comparator? What does it return, first of all? Int. And what does it take? 2 Pokemon? Const void star A and const void star B. Right? It ain't a comparator if it's anything else. Okay? Now, when you do comparators, the first thing you do is you typecast. I want to force those 2 generic void pointers to become 2 Pokemon, X and Y. It's equal to const void star A, and same thing for B. There we go, and Y. Okay. Now, once I've got those, I can compare their names. X's name, how do I get that? Is it dot or is it arrow here to get their name? Arrow because it's now a pointer, right? And Y is likewise, Y name. Now, how can I compare 2 strings? strcmp. Yeah, go ahead.
On the typecasting lines there, shouldn't we be const Pokemon stars A and B?
Oh, thank you. On the right-hand side. Yes, thank you. There we go. All right. So there is my, oops, go back over here. There is my comparator. Now that I've sorted it by name, I can use B-search to find the first Pokemon. So Pokemon A, star A is equal to B-search. Why did I go star on the left-hand side? Because B-search returns a pointer to the thing that it finds. Right? Now, B-search is really easy because these 4 things are always going to be the same. The only difference is that B-search takes another key at the beginning. Right? Likewise, for the second one, B. All right. Now, we're reading in from the command line, argv sub 1 and argv sub 2. Right? So let me put those into strings first of all. Char star Pokemon 1 A name, right, is equal to argv sub 1. And char star Pokemon B name is equal to argv sub 2. Okay? Can I use those as my key? What type is Pokemon A name? A, char star, which is a string. And that's my needle. Here's my haystack. Is my haystack a bunch of strings? Nope. Got to be apples to apples, oranges to oranges. All right? So how can I create a key for this? Pokemon key, A key. Right? Now, here's where it would really be nice to have that init function, right? So maybe I should go back and do that. I'll show you a really quick and dirty way of doing it. Right? Use the curly brackets here, and what you can do is you can put in a dummy ID, a name, and a type. So I think, hopefully this will work. So 0, it doesn't matter. Pokemon A name, and It doesn't matter. I'll just go with an empty string here. Right? If this doesn't work, then we will have to write the function. B and B. There we go. GCC. It's not going to let me do that. Or maybe there's another problem.
You never
Oh.
declared.
Pokemon. And that should be lowercase. Pokemon P. I've been doing way too much Python lately, which is a dynamic programming language, and you don't declare variables, right? And you get lazy. Right? All right, so okay, there we go. All right, the key, of course, is not compiling there. Even this is wrong, though, right? What does B search expect as its first argument? A void pointer, a const void pointer. And this is just a regular old structure. So how do I change that regular old structure into a pointer? Ampersand. And I need to do ampersand here. Pokemon A, or B name. Right? Now, we have to be careful here because, well, one, we could have screwed up our code, but two, the user could actually, give some, I don't know, foo and bar there. There. Is foo a Pokemon name? No. Is bar a Pokemon name? No. So we're going to want to do at least a little bit of rudimentary error checking here. Right? If A is not valid, in other words, you did not find what you were searching for through B search. First of all, how do you know that you did not find what you were searching for? Is null. Right? It'll return null in the event of an unsuccessful search. And if this happens, we'll just print out error recognized Pokemon %s and the line, and that's going to be Pokemon, what did I call it, name, A name. There we go. And let's just go ahead and exit on them, right? There's no reason to continue with the program if they can't give us a valid Pokemon name, right? Same thing for B and B, right? So if I compile this, and if I pass in foo and bar, right, then unrecognized Pokemon foo. Right? Give me a valid Pokemon. Yeah, is that how you spell it? Yeah. All right, bar. There we go. Oh no, that's not how you spell it. Flare. That's how you spelled it, isn't it?
In the two B searches, I don't think you ever put the dummy key inside.
Oh.
Still have strings there.
Thank you. What's wrong? I went to the trouble of making the keys, and then I never actually bothered to use them. There we go. All right, so GCC this now, and that is correctly spelled, right? Flareon. All right, A.out, Flareon bar. Right there, and that it's recognized now, but bar is not recognized. Do they fight each other? Flareon. All right, well that works. Give me another one just to be sure, though. Charizard. Okay, there we go. All right, so I think it works, right? Because we didn't get any error messages. Now I've got my Pokemon, and I've got their types. Right? Implicitly, I've got their types because they're being stored in this structure right here. Right? We're doing good on time. Now what I need to do is I need to open the DAT file, the data file, and find the versus pair, right? Okay, ... So once again, I'm going to open up a file. I can't reuse F here. Actually, did I ever close the other file? That's a good question. Nope. So what should I have done? But close F. Right? And now I can reuse F because F is closed. F is equal to fopen. And I'm going to open up that other file, which is Pokemon types.dat for the purposes of reading. And once again, I'll reuse the buffer as well. Right? And do I know exactly how many lines there are in that second file? I kind of do. There's going to be a type. If I have 151 Pokemon and that versus 151 Pokemon, right? Then how many possibilities are there? 22. Oh no, sorry. How many types are there? Sorry, not that many Pokemon. How many types are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is that correct? 18 times 18, which would be 324 combinations, and there we go. You got our answer. Okay. So I know how many up front there are. What I'm going to do though is I'm going to just go into a while loop, because I don't really care about like poison normal. If I eventually find like bug versus water, I'm done, right? I've got my answer. So let's just use that and quit. Right? So let's come over here and while true, I can do it like this. I will read in the line forgets, and that'll be into the buffer at most 1,000, reading from the same the file handle there. Right? And then I can use the same trick as before and split it out. Char tokens is equal to split of the buffer along. Now in this file, however, they are spaces. They're not commas, right? So space, and then what is it? Num tokens, and I probably have to declare that again because it was declared up in that other inside that loop up there. Oops, there we go. All right. I can check here too if the num tokens is not equal to 3. Something went wrong with the file here as well. Printf error with second file, right? And the line, and then exit on them. Right? Otherwise, I have these 3 tokens. Okay. Now I want to know: does the first token, this one, that's the attacking Pokemon, does that match the type of Pokemon A? And does the second one match the type of Pokemon B? Right? If so, I look at the third one, and there's my answer, and I'm done. Okay. So, how do I compare Pokemon A? Was it Pokemon A? What did I call it up here? I just called it A. I shouldn't have done that, but fine. A dot or arrow type is equal to tokens of 0. This is just pseudocode for now. And A or B dot or arrow, you're going to fill in the blank for me, type is equal to tokens of 1. Then I found what I'm looking for. Found it. Okay? So my first question here is dot or arrow. Remember that A is a pointer. So kind of like a mnemonic device here. That's probably why they made it into an arrow, because you have a pointer to it, right? And so both of those are going to be pointers, right? Is equal to tokens of 0. Remember that this is a char star, and so is this. How do I compare strings in C? strcmp. And if I compare them and they're equal, what would I expect that function to return? 0. Can't do and. Instead, that's ampersand. strcmp of B's type is equal to tokens of 0 equals to 0. Then I found it. I'm done. Okay? So printf, and what's the message we're supposed to be printing again? There we go. I'll copy that and then we'll fill in the blanks. There we go. End the line. All right. And so the first one is a name. Its type. The second one is a name and its type. And then this one is going to be %f or %2f. Let's do that. And so this will be A's name, A's type, B's name, B's type, and then finally the floating point number, which is tokens of 3, or tokens of 2. It's the third token. Tokens of 2 is the multiplier. Okay. So double multiplier because it's 1, 2, or 0.5. So multiplier is equal to, how do I convert that tokens 2 into a floating point number? A to F of tokens to 2. There. And this last one will be a multiplier. That's not correctly spelled. So there we go. That looks better. And at that point, I'm done. I can just exit. But I'm going to exit with a 0 error code indicating everything went fine. Right? So I'm kind of abusing this loop here and exiting immediately. We can clean it up later. Oh, okay, fine. If I'm going to use something true, it's going to have to include. Where is true false defined? Std bool .h. Clear this. There we go. And let's go ahead and try it again. Foo bar, I should get an error. A dot out. Let's go Jinx and Flareon. Jinx, Flareon. Yeah, that's half type damage. Give me another couple of them. E V E and what? Mu, like TWO? Is that how you spell it? All right. Is that correct? Normal versus psychic. Here's my normal, and then psychic is, well, where is psychic? Okay, so blank means normal up here at 100%, so one multiplier. All right. Okay. So that got the job done. We have 20 minutes now. Let's just observe. We won't necessarily fix them all, but let's observe some of the things that are wrong with this from a design perspective. First of all, I'm abusing the exit right here, right? What you could do instead is you could use a break instead, I guess. That would be slightly better, but I still don't like breaks because they're kind of like go-to style programming. And this one would just simply break out of this loop, right? GCC. And it's going to end up being the same thing, right? But it's breaking out of the loop and coming down here. Instead, what I would prefer to do something else, like I don't know. I would completely restructure this while loop here, right? I would have some sort of variable called, say, bool found is equal to false, and while not found, then keep doing this, and then I would say found is equal to true. Now that's a little bit better, right? Because it's kind of more English. Instead of forcing an infinite loop and then breaking out of that infinite loop, now you have a bounded loop that's bound to this variable right here, right? So stylistically, that's a little bit better. It's not going to change the behavior of the program, but that's a little bit better. Let's come all the way back up here. Oh, by the way, that means that I can now properly close the file. For close F. Because before, if I was just exiting here, that file never got technically closed. Okay? And it could have been corrupted. Luckily, it's read-only, so we didn't corrupt it. Right? But that's a little bit better. It's for close now. What else am I missing here? Free. In fact, let's come back all the way up here and let's look at all of the ways that I am not freeing things. Every time I split something, right? I use it, but then I never do anything with it, right? That's a memory leak. Let's see how bad this memory leak is, by the way. Val grind. Let's go with that, and then val grind. Right. So we're leaking a whopping 7,000 bytes. So 7K, right? Let's be a little bit better stewards of our memory, though. And this is why we gave this function down here. Free string array. Right? All we have to do is tell it how big it is, right? And it'll take care of it for us. Free string array of tokens. And how big is it? Well, that's why I stored it off into a variable there. Num tokens. Right? We make the same mistake down here when we're reading the second file. Right? After we're done with it, we should free it up. And once again, if I was exiting out of this, I would have no way of freeing it up. As it is right now, if you find what you're looking for, you're just simply setting this flag value to true, but you're still cleaning up after yourself before you come back up here to find that you found it to break out of the loop and close the file. That'll take care of some. GCC and run this again. 7,000 is now down to only 3,000. What else do we need to clean up? The Pokemon themselves. Right? So I'm going to iterate through that array. Actually, can I do this? Free Pokemon. Let's see if that cleans it up. So remember that it was 3624. Right. That cleaned it up a little bit. But remember, what else is in this array? Yeah, a name and a type. So what I'm going to have to do to make this completely clean is iterate over each element for int I equals 0, I is less than num Pokemon I plus plus, and free Pokemon of I dot name and type. I think that gets us probably down to 0. Hey, we did it. Right. 0 bytes and 0 blocks are lost. No errors in any context. We're good. So we've cleaned up after ourselves and made it a little bit nicer. Okay. How else could we improve this design? We're not going to do it, but yeah, all those to-dos that we did, right? Come back and fix this to be dynamic by reading it, by pulling out your functions from Lab 10 or Hack 10. Read in all lines from a file. That gets it done for you, right? And then you can then you don't have to open it up twice. You can just go ahead and iterate over it. You know how many lines are in that file. Probably put this into a variable instead. Another to do would be create an init Pokemon function so that you're not using this kind of syntax and you're taking these 3 lines and putting them into another function. Clean up the cruft. I know that the queue sorts. You don't need to tell me. Right? Find the first one. Yeah, I know that's finding the first one because it's Pokemon A and then there's Pokemon B. So clean up the cruft. Right? I do agree that this is okay to exit at this point because we're in the main. Right? If we were in another function and we had exit, that was definitely not the way to go. Right? Likewise, printing something, we're in the main, it's okay. It's not recoverable. We need to actually exit at that point. Right? Put that into a variable maybe. Right? Spell things right. There we go. But otherwise, that's pretty good. Right? Let's make sure we didn't break anything. And, well, okay, let's make sure we didn't break anything by, I actually want to know, was that correct? 1? Okay. What happens if somebody fights themselves? It's always normal? Oh, no? So that would be on the diagonal. Oh, wow, the diagonal. It looks like a lot of them are halvesies. Right. Is there anything that's double? Oh, this one. When a dragon fights a dragon? Give me a dragon. What is it? Dragonite? Like that? Dragonite. Okay. 2x damage. Cool. And again, if you have invalid, I don't know, foo, and unrecognized Pokemon. All right. So, again, redo week this week. You have one more hack, and that's going to be vibe coding hack to produce a battleship game. We already have the game running. It's on a server. You produce a client to connect to the server and play. Last time I checked, there were like 4 or 5 people that had completed that and won a game. There are a couple dozen more people that have connected and created a game, but they haven't won a game yet. That could just be that I'll play it later or something like that. But it's pretty easy to win, right? Just carpet bomb and then probe. There's somebody that tried to get the AI to produce an AI player that would then play the game automatically, and they couldn't get it to, at least according to their README file, they couldn't get it to probe correctly. Right? Once you got a hit, you go north, south, east, west to see which way it's oriented until it gets sunk. And it wasn't able to do that. And so they just gave up and won the game manually. Right? So you've got that one, and you've got the 2 PDC modules that you still need to complete the surveys on those. And then what else is there? The bonus opportunity. We can look it up really quick here. Okay. We were up to 50% last time. I'm sure that we're up to maybe 60% now. So make sure that you are encouraging each other to finish that out. Otherwise, next Wednesday, 1 week from today, is your final exam. So I'll see you then.